Algebra 2, Module 4, Lesson 19. This is sampling variability in the sample mean. So, students are going to understand the term sampling variability in the context of estimating a population mean. Students will understand that the standard deviation of the sampling distribution of the sample mean conveys information about the anticipated accuracy of the sample mean as an estimate of the population mean. This lesson uses simulation to approximate the sampling distribution of the sample mean for random samples from a population. It explores how the simulated sampling distributions provide insight into the anticipated estimation error when using a sample mean to estimate a population mean, and covers how sample size affects the distribution of the sample mean. Okay, so here we have, for exercise 1 through 6, we have SAT scores. Number 1 says SAT scores. We're over here on this side. It says the table on the next page displays the 506 scores for the students in one New York school district for a given year. And here they are. There's 506 scores. And it just so happens that they're the last number, the last score is 506. So looking at that table, how would you describe the population of the SAT scores? Wow. So this is a bunch of scores here. Now, just by taking a glance at that, the easiest way to talk about it would be maybe to give the range, what's the highest and the lowest, and even that is hard to find. I'm looking to see, I see a 722, so that looks like a high right now of 722 right there. Looking for a low. I don't see anything in the 100s, I don't think. So maybe a 200. See if there's anything in the 200s. Not seeing anything in the 200s. Maybe I'm just not looking carefully enough. Oh, wait. There's a 158. And then there's a 779. Okay, so let's just say that we can stop there. There's about 158 to 779. That's the way I would describe that. Okay, it ranges from that, so it's hard to tell. I see numbers as low as 198. No, mine's 158, and others in the 700s. Cannot tell much from looking at the individual numbers. Okay, so yeah. All right. B says, Jason used technology to draw a random sample of size 20 from all the scores and found a sample mean of 487. What does this value represent in terms of the graph below? So that would tell us that the mean is about right here. Okay, does that make sense? Well, since we have some down here around 350, a little above 350, and we'll call this what, 625? That seems to be a little low, I would think. I think it might be a little bit higher. But yes, that sounds reasonable. So it says this represents the average SAT score of the samples and indicates where the scores in the dot plot are centered. If you computed the mean of the values of SAT scores in the sample, you have, okay, yeah, so 350, a few over 350, 625, and you would find the mean SAT scores to be 487. Yeah. All right, so if you were to take many different random samples of 20 of this population. Describe what you would think the sampling distribution of these sample means would look like. Well, based on all we have to go on right now, we would say that they're going to be centered around 487. Okay. And they would range anywhere from around 350 to not 625. Because that's the only information we have to go on right now. Okay. Let's see here. Sampling distribution of the samples may be centered or on a value close to 487. The spread would be similar to the example above. Yep, that's what it says. All right. Page 2. It says everyone in Jason's class drew several random samples of size 20 and found that mean SAT score. The plot below displays the distribution of the mean SAT score. So this is not what they pulled. It's the means of what they pulled. So they pulled 20 and found the mean of that, and then these are the plot. The dot plots represent that. So A says, how does the simulated sampling distributions compare to your conjecture in exercise 2? Well, it's pretty close, right? We said that it should be centered around 487, which would be right around in there. Okay. Here we have a sample of about 420 to 530. Okay. So it's actually narrowed a little bit because we said 350 to 625. So it's actually narrowed some. Okay. And that's probably just all that's going to say. Estimate the sample to be a bit higher than it seems to be in the simulated distribution, but yeah, that's what it says there. All right. B says use technology to generate more samples of size 20 and plot the means of those samples. Describe the shape of the simulated distribution of a sample mean. Okay. Let's act like we've done that. And there it is. How would we describe the shape? Well, definitely going to be normally distributed. Okay. And what's the distribution of the sample mean? Well, it should be found right around in here, which would be, here would be 470. This dot or this line right here would be 470, so it's going to be right around 480. Okay. So it says following displays an example of a simulated distribution of sample means from random samples from district SAT scores. The distribution is normal. The mean of the sample SAT appears to be around 480, and the sample mean scores range from a little over 420 to 530, which is what we said it should do right here. It's actually closer to, 530. 530 is right on it. Okay. All right. How did the simulation distributions using more samples compare to the one you generated in exercise 3? Well, they were very close, right? The maximum and minima were nearly the exact same on both distributions, 420 and 530, and a little over 420 to 520. So that the mean SAT scores, the simulated distributions of sample means is in both seem to be about 480. That's what we said. All right. What are the mean and standard deviation of the simulated distributions of sample mean SAT scores you found? Use technology and your simulated distribution of the sample means to find the values. So hopefully you know how to do that. Add them all up, divide by the number that you have added up, and that will give you the means. Now to find the standard deviation, what I would do is just plug it into a calculator and know your formula on how to do that. So the mean SAT score of this simulated distribution of sample mean is 478, which is close to 480, and the standard deviation is about 21.5. Now, write a sentence that describes the distribution of a sample mean that uses the mean and the standard deviation you calculated in Part D. Well, what we could say is, since we know that standard deviation is 21.5, and we know that the mean is 478, we know that 95% of our value should fall within two standard deviations. So that would be 43 is two standard deviations. If one is 21.5, two would be 43. So we would need to say 478 plus 43. What is that? 521, and then we need to subtract it as well to get the two standard deviations below the mean. Okay, and so there's going to be your that's going to be your range. Okay, you should know that between 435 and 521, about 95% of our values fall in between, or SAT scores fall in between that. Okay, let's see what they said. Almost all of the SAT scores are within two standard deviations from the mean, 435 and, 521. Okay, this says, reflect on some of the simulated sampling distributions you have considered in previous lessons. Make a conjecture about how you think the size of the sample might affect the distribution of the sample SAT means. Well, as I've been saying for days now, as the sample size increases, the distribution or the variability or the standard deviation will decrease. As the sample size increases, the distribution should decrease. Okay, so what that means is, if you're looking down here at the graphs, notice as the sample size increases, they start narrowing in. So let's see what this says. The larger the sample size, the smaller the spread of standard deviation. Yeah. To test conjecture, investigate the sample sizes 5, 10, 40, and 50, and the simulated distribution of sample means from exercise 3. Divide the sample sizes among your group members and use technology to simulate the distributions of mean SAT scores for samples of the different sizes. Find the mean and the standard deviation of each simulated sample distribution. So you all know how to do that with a calculator or Desmos or whatever technology you use. So I've already included them. Now, this is the sample size. Let me see if I can zoom in right here. This would be a sample size of 5. Okay. If you only take 5 samples, you find the mean, and that is what is plotted here. Okay. Now, a sample size of 10 is here. Notice this is ranges pretty wide here, and then it is narrowing down. This is sample size of 20, and it's narrowing down. Here is a sample size of 40, and then here's a sample size of 50. Okay, although the majority is found here. Okay, so you can tell, and if you just look at the standard deviations that you calculated, they are shrinking. They're getting smaller. They are decreasing. Notice, though, that the means still remain about the same. somewhere between 470, 468, and 478, the means should stay the same, roughly the same, but your standard deviation should decrease. So the following represents sample. Okay, yep, that's what we just talked about. Now, C says, how does the sample size seem to affect the simulated distributions of the sample SAT mean scores? Include the simulated distribution from part B of exercise 3 in your response. What do you think is true? So as the sample size increases, we know that the spread decreases. The standard deviation went from 40 from a sample size of 5 to about 14 with a sample size of 50. We see all of that right here. Okay. Now, the mean of the sample distributions of the mean SAT scores varied from 468 for the distribution of the samples of size 10 to 478 for the sample size of 20. I would expect that a bigger sample would be more likely to look a lot like the population. So the bigger samples would not tend to be as different from any or from one another as smaller samples. And what that means is if you're getting a higher sample size, of course your mean should be getting closer to the actual population sample or mean. Okay. Because of this, the sample means would not differ as much as the sample to sample for bigger samples. So even if we went all the way up to 100, it's not going to be far off from 476. Okay, just like a sample size of 10 here is only 468. It's not going to be that much different. All right. This says, for each of the sample sizes, consider how the standard deviation seems to be related to the range of the sample mean in the simulated distribution of the sample SAT mean. Okay. In each case, nearly all of the sample means are within 2 standard deviations of the mean or are a normal distribution. Yeah, we know that. No matter what we do, whether we're looking at sample means or whether we're looking at any type of distribution in a normal distribution, we know that almost all of the values should be within 2 standard deviations. Right? So how do your answer to part A compare to the answer from other groups? Well, if we were to do this, it would all look about the same. Okay, you would have your mean where everything's centered around it, and depending on the sampling size, that would be depending on how spread out they are, but they would all be normal distributed. All right. Make a graph of the distributions of the population consisting of SAT scores for all the students. So if we went back to that chart and made a graph of all those dot plots or all those dots, notice that you have probably about 2 standard deviations here and here. And then this would be kind of your tail with the other percentages. Okay. This says find the mean of the distribution of SAT scores. How does it compare to the mean of the sampling distributions in which you have been simulating? So if we look, we would probably say that the mean would be found somewhere right in here. So if this is 450, this would be about 475. So probably some from 475 to 500. Well, it's exactly 475. This is close to the means of sampling distribution, yeah, because we went from 468, I think, to 478. So that is correct. And just by looking at this graph, I probably needed to consider some of these down here in these over here. Would probably shift that from from 500 on down to 475. Okay. So in this lesson summary, it says there's a variability in the sample mean. Remember, we're talking about sample means. We're taking 5 samples and we're finding the mean of those and then plotting. Taking 50 samples, finding the mean, and then plotting. That's what we're talking about with sample means. The value of the sample mean varies from one random sample to another. A graph of the distribution of sample means from many different random samples is a simulated sampling distribution. Sample means from the random samples tend to cluster around the value of the population mean because samples should be representative of the population. That is, the simulated sampling distributions of the sample mean will be centered close to the value of the population mean. The variability in the sample mean decreases as the sample size increases. Most sample means are within 2 standard deviations of the mean of the simulated sampling distributions.